Dear student, let's start the new chapter, new topic, that is the limiting factor. Basically, this term should not be new for us. Why? Because we did study throughput accounting. In throughput accounting, students, if you just try to recall, instead of using the terminology limiting factor, we were using the terminology bottleneck resources. Actually, what limiting factor does, it restricts your operations. Due to limiting factors, you will not be able to, let's say, fulfill the entire demand. So basically, limiting factor, it restricts your level of activity. Now, there are two possibilities when it comes to scarce resources, limited resources, limiting factor. What are the two possibilities? One possibility is there is only a one limiting factor, which we are going to discuss first. That there is only one limiting factor, which could be machine hours, labor hours, material availability, kgs. And there's another possibility also that there are more than one limiting factors. Actually, when there are more than one limiting factors, that in that situation, we go for linear programming to deal with that. But right now, in today's lecture, we will be just focusing only on one thing. That is, if there is only a single limiting factor, then how do we utilize our available resources to make sure that we are making the maximum profit? Actually, in the short term, we know that fixed cost will not vary. It will remain same. So maximization of profit means if you can achieve the maximum contribution. So automatically, when the contribution is maximum, your profit will be maximum. So first we'll be discussing, in case of a single limiting factor, what should be done, how to make a production plan, how to make sure that contribution will be maximized. Then from the next class, we will be studying the linear programming. Planning with the limiting factors. One limiting factor, key factors analysis. Actually, if there's a one limiting factor, so step one is, first you have to actually identify the limiting factor. Let's say you have identified them. Then you simply calculate contribution per unit. Then you simply calculate contribution per unit per limiting factor. Then obviously, the product which is giving us highest contribution per unit per limiting factor, that has to be manufactured first, and so on. Multiple limiting factors. Then we go for linear programming. We will study graphical and algebraic solution both. Even though we know that now, due to this CB format, nobody will ask you to draw the graph in exam, but obviously you should know the interpretation. But that's what we'll be discussing in the next video. Right now, just focus on one limiting factor. Then we will also study in the next video what do you mean by shadow and crisis and slack. Now, firms face many constrained means limiting factors on their activity and plan accordingly. Your demand could be limited. Limited skill, labor hours, other production resources, limited finance, capital rationing. That's what you people study in financial management. Examination question focus on the problem of scarce resources that prevent the normal plan being achieved. So what is scarce resources they will do? They will prevent you from the normal plan to be achieved. Example, firm facing a labor shortage this month due to sickness and as a result cannot produce a number of units, it would be like, how should its production plan be revised? Planning the limiting factor. Now, this is important. If there is one limiting factor, then the problem is best solved using the key factor analysis. Step one is identify the scarce resources, means identify the limiting factor. So actually, first you have to identify the limiting factor. That is step one. Basically, you have to identify which factor is limiting. Is it the labor hours, machine hours, material availability, what it is actually? Or let's say the demand, what it is. Calculate the contribution per unit for each product. Step one, identify the limiting factor. And let me tell you, limiting factor is always identified at the maximum demand. For example, if you come across a question where two types of demands are given, one is normal demand, another is maximum demand. Limiting factor is always identified at maximum demand. Step one, identify the scarce resources, identify the limiting factor, and never forget the concept. Limiting factor is always identified at the maximum demand. Step two, calculate the contribution per unit of the scarce resources for each product. So in step two, what are you going to do? You will be calculating the contribution per unit. Step two, contribution per unit. Then step three is calculate contribution per unit of scarce resources. So whatever contribution per unit you have calculated, divide that with the limiting factor, which is required to produce 1 unit. Identify the limiting factor, step one, contribution per unit, step two. And third, what do? We will simply divide the contribution per unit with the limiting factor required per unit. Step four, rank the products in order for the contribution per unit of the scarce resources. So whatever ranking you have decided in step three. Now, basically, according to that ranking, you will go for the production mix. Step five, allocate the resources using this ranking and answer your question. Now, let's see a question that will give you a really good idea how to use this 5-step approach. Indicate the production levels that should be adopted for the 3 products in order to maximize profitability. We have already discussed where your contribution is maximum, your profitability will be maximum, because in the short term, we know that fixed costs will not change. And state the maximum contribution. Let's see. X Limited makes 3 products. X Limited makes 3 products. X Limited makes 3 products, A, B, and C, for which unit cost, machine hours, and selling prices are as follows. So X Limited makes how many products? 3 products. That is A, B, and C, for which unit cost, machine hours, and selling prices are as follows. Product A needs 10 machine hours. Product B needs 12 machine hours. Product C needs 14 machine hours. Direct material is 50 cents per kg. 50 cents per kg. Okay. So one unit of product A needs 14 kg. 14 multiplied by 0.5 is $7. Product B needs 12 kg into 0.5 is 6. Product C, 10 kg into 0.5 is 5. 7.5 per hour variable overheads. So we have direct wages at the rate 7.5 per hour, direct wages. The rate is 7.5 per hour. Product A, 1 unit of product A needs 1.2 hours of labor. 1.2 multiplied by 7.5 gives us 9. 0.8 multiplied by 7.5 gives us 6. 0.4 multiplied by 7.5 gives us 3. Then we have variable overheads. Here comes the marginal cost means variable cost, selling price. So examiner has already done one step for us. Contribution per unit per product is given to us. So contribution per unit ABC is already calculated. Fine. Sales demand for the period is limited as follows. The demand for product A is 4,000 units. Product B is 6,000. C is 6,000. Company policy is to produce a minimum of 1,000 units of product A. Company policy is to produce a minimum of 1,000 units of product A. Now, students, please listen carefully. Whenever there's a company policy to produce certain units of any product, then no matter whatever the ranking comes, that those minimum units you have to produce. No matter whatever ranking comes, you have to fulfill the minimum requirement because of the policy. The supply of materials in the period is unlimited. So when examiner writes that supply of material is unlimited, so simply material cannot be a limiting factor in this question. Why? Because it is categorically written that supply of material in the period is unlimited. So simply material cannot be the limiting factor. But machine hours are limited to 200,000 hours. So we have to check, is it machine hours a limiting factor? Because if required hours are more than, for example, 200,000 and available is less than that, then it is a limiting factor. We also have been given a direct labor hours. So actually we need to check either the machine hour or the labor hour. One of them is going to be the limiting factor. Both cannot be the limiting factor right now. Why? Because we are just studying right now. If there is a single limiting factor, how to deal with that? So let us go for step 1 to identify the limiting factor. Simply step 1. Identify the limiting factor, identify the scarce resources. Identify the scarce resources. Okay. Products. We have 3 products, A, B, and C. Demand in units. 4,000, 6,000, and 6,000. 4, 6, and 6. Now let's come to machine hours. A needs 10 hours, B needs 12, and C needs 14. Please, 1 unit of A needs 10 hours. So 10 multiplied by 4,000 will give us 40,000 hours. 10 multiplied by 4,000. 12 multiplied by 6, 14 multiplied by 6. 12 multiplied by 6,000. 12 multiplied by 6,000 will give us 72,000 machine hours. 14 multiplied by 6,000 will give us 84,000. So let's see. 40,000 plus 72 plus 84 gives us 1,96,000 hours. So simply machine is not a limiting factor. Why machine is not a limiting factor? Because available machine hours are 200,000. And we just need 1,96,000. So obviously available machine hours are more than the required hours. So when you have available hours more than the required hours, so simply there is no limiting factor. So right now, machine hours is not your limiting factor. Now let's check for labor hours. One unit of product A needs 1.2 hour of labor. 1 unit of product A needs 1.2 hours of labor. The demand of product A is 4,000. So 4,000 multiplied by 1.2. 4,000 multiplied by 1.2, we are getting 4,800 hours. How did I get this 4,800 hours? 1 unit of product A needs 1.2 labor hours. The demand of product A is 4,000. So simply 4,000 multiplied by 1.2. So we get 4,800. Product B. 1 unit of product B needs 0.8 hours of labor. The demand for product B is 6,000 units. 6,000 multiplied by 0.8. 6,000 units of product B multiplied by 0.8. 1 unit of product B needs 0.8 labor hours. So 6,000 multiplied by 0.8 gives us 4,800 hours. C. The demand for product C is 6,000 units and 1 unit needs 0.4 labor hours. So for C, 6,000 multiplied by 0.4. So I'm getting 2,400. So total labor hour required is 12,000. Available labor hours, we have only 5,000. We need 12,000. We have only 5,000 labor hours. So simply the labor hours are the limiting factor. So simply labor hours are the limiting factor. In step 2, what do? We calculate contribution per unit, but that is already done by our examiner, I would say. Products A, B, and C. Contribution per unit. Contribution per unit. A is having a contribution of 6, B is having 5, 4, 6, 5, 4. 6, 5, 4. We have already decided the limiting factor is labor hour. So let's divide the contribution per unit with the labor hour required for 1 unit. Labor hours required for 1 unit. 1 unit of product A needs 1.2 hours of labor. 1 unit of product B needs 0.8 hours of labor. 1 unit of product C needs 0.4 hours of labor. Here comes the contribution per labor hour. Contribution per labor hour, or you can say per limiting factor. 6 divided by 1.2, I'm getting $5. 5 divided by 0.8, I'm getting 6.25. 4 divided by 0.4 gives us 10. Wow. Ranking. Ranking will be on the basis of obviously where we are having the maximum contribution per limiting factor, that has to be manufactured first, second, and third. So simply the ranking is C is number 1, B is number 2, A is number 3. Fine. Before making the production mix, never forget one thing. What is that? Company policy is to produce a minimum 1,000 units of product A. Company policy is to produce a minimum 1,000 units of product A. Now listen carefully. I did mention at the start of the question, whenever you have such a policy, irrespective of the ranking, first you have to fulfill that minimum requirement. So it means first, obviously, we have to go for product A, but only 1,000 units. Because on the ranking, A is not number 1. So because of the policy, only 1,000 units of A will be produced first. Then obviously we'll go towards C, which is rank number 1. And we will maximum satisfy the demand of C. After that, if any resources are left, we'll go for product B, assuming after fulfilling the demand of product B, if the resources are still left, labor hours are, for example, is still left, then we'll come back to product A. Repeat. Even though according to the ranking, number 1 is C, but because of the company policy, irrespective of the ranking, we have to manufacture, we have to produce first at least 1,000 units of A. Then we'll go for C to produce the maximum unit of C. So let's try to make the production mix now. So let's see. Units produce. Then we'll take the labor hours because we have only 5,000 labor hours. Then we'll see the cumulative labor hours means total labor hours. Cumulative labor hours. Okay, now we have to produce minimum 1000 units of product A because of the policy. So let's go for products. A, no choice at all. You have to produce 1000 hours of 1000 units of A first. 1 unit of product A needs 1.2 hours. So 1200 hours. Now we'll go for the ranking, of course. Now let's go for C and fulfill the maximum demand of C. The maximum demand of C is 6000 units, and 1 unit of C. 1 unit of C requires 0.4 labor hours. 1 unit of C requires 0.4 labor hours. So 6000 multiplied by 0.4, we get 2400 hours. 1200 we have already used to produce 1000 units of A plus 2400. So cumulative will become 3600. Now, according to the ranking, of course, we'll go for product B, but we have to see how many units of product B can we produce? Can we produce all 6000 units for B or less than that? Basically, available hours, we have only 5000. We do not have more than 5000. So logically, please try to understand. Available hours are 5000 and we have already utilized 3600. So the remaining hours are 1400 hours. Repeat. Labor hours are only 5000. Out of 5000 labor hours, we have let's say, utilized 3600 labor hours. We are left with 1400 labor hours. Now let's see, come here. We have only 1400 labor hours. 1 unit of product B needs 0.8 hours of 0.8 labor hours. We only have now 1400 hours. So 1400 divided by 0.8 will give us how many units for product B we can produce. It is 1750 units. So the maximum units now which we can produce for product B, that is 1750 units, even though the available demand for product B is 6000 units, but we cannot fulfill. Because total labor hours available, we have 5000. Out of that 5000, we have utilized 3600. So the remaining balancing figure is 1400 hours. How did I get 1750? Very simple. Units produced is equal to I've taken available labor hours, divided by time, labor time required per unit. Labor time required per unit. So now we only left with 1400 hours and 1 unit of product B needs 0.8 labor hours. So we can maximum produce 1750 units. So simply, you can say 1400 is a balancing figure. And we can maximum produce 1750 units. Multiply by 0.8, it will give you 1400. And obviously, we'll get 5000 cumulative hours here. How did I get 5000? 3600 plus 1400. Okay. Now, basically, if you just mention few more things, why we are producing product 8000 units, that is policy to produce 1000 units. So just for more clarity. Otherwise, whatever you have done, it is good enough. But okay. Let's say that. Note. Policy to produce 1,000 units sales of product A. That is why we did this, and limiting factor is labor hours. So limiting factor is labor hours. Now let's see how much maximum contribution we can generate. We know that where the contribution will be maximum, then obviously profit will be maximum. Maximum contribution. Products A, B, C, there's no issue now. We'll be just manufacturing 1,000 units of A. Contribution per unit is 6. Here comes $6,000. We'll be manufacturing 1,750 and contribution per unit for product B is 5. 1,750 into 5 we get 8,750. And we will be manufacturing entire 6,000 units for product C. Contribution per unit for C is $4. 6,000 multiplied by 4 is 24,000. So that is 38,750 is the maximum contribution. Students, please, when we are just calculating the maximum contribution, I've just written ABC. Do not get confused with this. Why? Ranking is already decided, and the units which we have calculated. Basically, why did I take 1,000 units? Because of the policy. And definitely, according to the ranking, we, after obviously product minimum, after meeting the minimum requirement of A, we have to go towards C. And for C students, maximum units which we can produce, that is 6,000. After that, we have calculated 1,750 units of product B. So what I really want to say, the way I'm calculating maximum contribution, please do not get confused with this. Sir, why you are showing the contribution of product B first, then the C? Student, listen, if someone does this, 1,000 multiplied by 6, C, 6,000 multiplied by 4, and B, 1,750 multiplied by 5. Still, you will get the same, I would say, contribution. The total contribution will be same. So basically, either you are calculating maximum contribution like this or just doing ABC. No issue at all. The main thing is how you have calculated how many units will be produced. That is more important. That is the main thing. So final, when we are calculating the maximum contribution, so presentation should not be a matter. Either you are writing ABC while calculating maximum contribution, or someone is writing ACB. In both the cases, your total maximum contribution will remain same. The main logic is this step, where we are just showing the production mix, how many units of each product will be produced. So here we have decided A is going to be 1,000, C is going to be 6, B is going to be 1,750. Here we have properly utilized the limiting factor. We followed the ranking, each and everything. So final answer of maximum contribution, if someone is writing ABC or ACB, it is not a problem at all. Okay, that is why I'm going with ABC. If someone is going for with ACB, it is perfectly fine. It is acceptable. So student, let me just give you what exactly we did in today's class. Basically, in this class, we just discussed if there is a single limiting factor, how to deal with that. Number one, you have to identify the limiting factor, which we did in this question. Second, calculate contribution per unit, which was already there in the question. Third, calculate contribution per limiting factor. Then, where we are having a contribution per limiting factor maximum, that has to be number 1, 2, 3, and so on. But before going for the production mix, if there is any policy of the company to produce minimum unit of any product, so first we have to produce those minimum units, and after that we have to follow the ranking properly. Now, student, inshallah, in the next class, we will discuss if we have more than one limiting factor, how to deal with that. So when you have more than one limiting factor, we deal with that scenario under linear programming. So we will start the linear programming from the next class. So thank you very much for watching this lecture.